Now we have to be continually go with that the Q learning algorithm process in this episode. The first one, Q table initialization, and number 2, observation, number 3, action, number 4, update, and number 5, repeat. So first one, the Q table initialization. The first step of the Q learning is to create the Q table as a place to track each action in each state and the associated progress. What we discussed in that previous video said there, I showed that is the one matrix. So it is called that is the Q table. And next one we have to be go with that observation. The agent needs to observe the current state of the environment. And number 3 is called the action. The agent choose the act in that environment. Upon the completion of the action, the model observes if the action is beneficial in that environment. So the action that should be completed, and upon the completion of that every action, the model that has to be observed how much the beneficial it's happened in that environment. And fourth one is called that update. So in that update, after that action has been taken, it is time to update that Q table with the appropriate results. So the table should be updated after with that each action that has been taken. And finally we have to be go with the steps from 2 to 4. That means again we have to be continually going with that observation, action, and update. So these 4 steps, these 3 steps from 2 to 4, that should be happen until the model has to reaches the termination state or the desired objective or the goal. So until the model has to reach the goal, we have to be go along with that observation, action, update. So these steps that has to be repeated. So now after the computation of the Q matrix, so from that outcome, so what should we have to do? So the gamma factor is discounting that factor for the future rewards. That should be that it's in that range of that 0 to 1, means the gamma that lies between 0 and 1. So the future rewards are less valuable than current rewards, or so they must be the discounted. If the value of the gamma, that is the new gamma value, that may closer to the 0, the agent will tend to consider only the immediate rewards. That means if the gamma that is closest to 0, the agent has to accept that immediate rewards. If a gamma is closer to 1, the agent will tend to consider only the future reward with the higher edge weights. So by the gamma alone has to be determined how the model that has to reach out to its destination by gaining the rewards. So the future rewards that should be less than that value of the gamma, that should be the discounted. If that the future model, its positioning related, that's close to that value of that 0 related with that gamma, then it has to go with the consideration of that immediate reward. If the gamma value is closer to that 1, the agent should consider for that future rewards with that higher edge of the weights. So now quickly we have to be see what's that Q learning algorithm. So first of all, we have to be set that gamma parameters, set environment rewards in matrix or initialize matrix Q as the 0, and then select random initial source state, set initial state S equal to current state, and then go with that one action and make that appropriate possible action, and then go for the next state of that S, and then observe the reward and get the maximum Q. So this is the sequence happening in the Q learning algorithm. Finally, we have to be apply the computation of q of s comma a, and then so repeat the step according to that gamma value. So what we have obtained in that q learning algorithm. And continually we have to be see what are all the major advantages and disadvantages of that q learning algorithm.